Okay, dimensional analysis, some things I want to cover. So distance, mass, velocity, time, acceleration, and force. Cool. So how are each of these things measured? Distance is measured in meters. Mass is measured in kilograms from the MKS system. Velocity is measured in meters per second. Time from the MKS system measured in seconds. Acceleration is meters per second squared, or could also be meters per second per second. That's for acceleration. Force is going to be in two things, and that's going to be newtons or kilogram meters per second squared on the bottom. For force here, a thing I want to make a note on is that if we look at Newton's second law, it tells us that force equals mass times acceleration, F equals ma. So acceleration is m over s squared, mass meters per second squared, and then a, or m, is measured in kilograms. So if we mass multiply those together, force equals kg m over s squared. So that's how we get this number here for that. So then in dimensional analysis, it's how do we solve problems using this system. So some things like I was looking at earlier, if we took, can we add units together? Yes, we can. So if we take 5 meters plus 3 meters, that's going to equal 8 meters. So we can do this sort of problem. This is okay to do because we have same units. But if we take 5 meters plus 3 meters per second, we can't do this because this is a distance and this is a velocity. We know this from up here. So because this is a velocity, we can't add we're going at a certain speed plus a distance. You can't add those. They're two separate things. So then another rule I want to look at. What if we have 5 times 3 meters? What does this equal? This is going to equal 15 meters. Why? Because if I took 3 meter boards and I had 5 of them, then I'm going to get 15 meters total. So that's just, this is, multiplication is just a repetition of adding. So we can still do that because it's the same meter, or because it's the same distance. So multiplying, you can do some things. Also, you can multiply different units. So if I take 6 meters per second times 3 seconds, what do I get? The answer is, so I'm going to look at the units first. So I have m over s times s. So the s's cancel, and I'm going to get meters. So meter is my unit, and then 6 times 3 is 18. So 18 meters. Then I also want to look at squaring things. So if I have 6 meters per second squared, what do I have? So if we look at the units, we're going to have meters squared over s squared and 36, because 6 squared is 36. So that would be our answer to this. So what if we have the cube root of 8 meters cubed? What would this get us? The answer to this is what? 2 meters looks good. And the reason 2 meters is good, the reason 2 meters works is because if we take 2 meters and cube it, multiply it by itself 3 times, then we get back to 8 meters cubed. And so that's some things we can do when working with units. Apply the algebra that we know to the units first and then work out the math with the numbers. So that's kind of some stuff in dimensional analysis for physics.